Hello everyone, this is Gautami, Shri Venkateshwar College of Engineering. So today we'll be discussing about the four-stroke petrol engine. So we'll be discussing about the parts and the four types of strokes in it and concluding it with a graph. So we'll move on to the topic first. So four-stroke petrol engine. Okay, to basically say about four-stroke petrol engines as a word says, it's used in a petrol engine where the petrol is converted into an energy, so the vehicle has to move. So then this four-stroke petrol engine consists of a cycle which continues for two revolutions and it is divided into four parts. So it's nothing but the section stroke, the compression stroke, the expansion of the power stroke or the exhaust stroke. So before going into this, we'll see about the parts of petrol engine. So as you can see that this is the spark plug, the fuel engine. This is the main difference from the petrol engine and the diesel engine. Need to be noted. The rest remains the same. So the exhaust valves, where the gas is escaped out, the inlet port, the connecting rod it supports both the piston and the crankshaft. So basically, it's like it helps in the movement. So while the up and down movement or the linear movement is converted into a rotational movement. So the crankshaft and the crankcase, which is used as a protecting machine for the part. So the piston. Here the piston plays a very important role because the piston is the one which converts or compresses all the gases or which helps in injection process or it is basically where the part where all the stuffs like conversion, compression, the pressure building up, everything takes place. And then we'll move on to the first part, that is section stroke. Intake stroke occurs when the air-fuel mixture is introduced to the combustion chamber. In this stroke, the piston moves from the TDC, that is top dead center, the fastest position, to the piston to the crankshaft to VDC. The movement of the piston towards the VDC creates a lower pressure area in the cylinder. The inlet valve remains to open to a few degrees to crankshaft rotation after VDC. So the intake valves then closes and the air-fuel mixture is sealed in the cylinder. So what are the points to remember is that during this section, the inlet valves remains open, the outlet valve is closed. So we'll see in a diagram over here. As you can see here, the inlet valve is being opened, whereas the outlet or the exhaust valve is closed. So what happens to this inlet valve? All the fuel plus air mixture actually enters through this. So as it enters, you know that the piston starts moving towards the down part. As the piston starts moving toward the down part, the fuel is being introduced into the chamber. So what happens basically the volume increases. So this thing takes place in the section stroke. We'll move on to the next stroke, which is a compression stroke. In compression stroke, the trapped air-fuel mixture is compressed inside the cylinder. During the stroke, the piston moves from the BDC to TDC, compressing the air-fuel mixture. The momentum of the flywheel helps the piston move forwards. Compressing the air-fuel mixture allows more energy to be released when the charge is ignited. The charge of the volume of compression air-fuel mixture trapped inside the combustion chamber readily for ignition. The inlet and the outlet valve must be closed to ensure that the cylinder is sealed, resulting in the compression. So in this case, we'll see that the inlet valve and the outlet valve is closed. So what happens in this actually? So as you can see, the air and the fuel mixture will be already inside the cylinder. So the inlet valve is being closed, even the exhaust valve is being closed. So as the piston was down, like piston was in the bottom, so now the piston will be moving towards the top, which is nothing but it is going to compress the air and fuel mixture. So basically what happens, both the outlet and the inlet wall has been closed. So there builds up a pressure where the air is getting compressed and then when the fuels are getting compressed so that the ignition part can be taken in a best way. So next comes the power or the combustion stroke. So the second rotation of the crankshaft begins when it completes a full rotation during the compression stroke. The power stroke occurs when the compressed air-fuel mixture is ignited with the help of a spark plug. Ignition or combustion is the rapid oxidizing chemical reaction in which a fuel chemically combines with oxygen in the atmosphere and releases energy in the form of heat. The hot expanding gases force the piston head away from the cylinder head. So In this, points to remember is that inlet wall is also closed and outlet wall is also closed. So in this case, it is same as the previous one, compression stroke. So what is the difference between these two? So as you can see that in the suction stroke, we had seen the piston moving downward. In the compression, it had to move up, and again it's coming down. So we'll take this like a second revolution, or we're just doing it second circle. So before the piston moving down, the spark ignition has been ignited so that the fuel catches the fire. So the because of the fuel, because of the ignition, because of the spark, the fuel and the mixture in it gains an energy to expand themselves to increase the power, where the pressure and the volume both are increased, making the piston to come downwards. So the piston starts moving down. So the next thing is for the piston to move up. So we'll see which stroke it is. It is exhaust stroke. As the piston reaches the VCD during the power stroke, combustion is complete and the cylinder is filled with exhaust gases. The exhaust valve opens during the stroke, and the inertia of the file wheel and the other part pushes the piston back to TDC, moving the exhaust gases to the open exhaust valve. At the end of the exhaust stroke, the piston is at TDC and one operating cycle has been completed. So in this, key points to remember is that the in valve is closed where the outlet valve is open. So we'll see in a diagram now. So as the first thing we notice is that the inlet valve is being closed where the exhaust valve is being open. So what happens? Then the spark has been ignited, the piston starts moving down. As the spark has been ignited, there has to build up a few gases, or we can say a few of the outletting gases, which is we can see even the vehicles coming out. But that is basically these gases which is coming out after the process. So these gases will be escaped towards the exhaust stroke. So after the completion of one circle, that is two revolutions taking place, the piston will be in the top position. That is for the suction to again takes place. So what happens in the suction is that the piston moves from the TDC to BDC. So that has to take place means the last position of the piston should be in the top. So the piston comes to its position again. We'll see this in a graph now. So pressure volume is being located in the graph with y and x axis. So in this cycle, we can say it is based on the O2 cycle, so where the volume remains constant. The air and fuel mixture comes inside the piston. So what happens here is that the volume is being increased. So we can see that the pressure and the volume remains constant. There is no difference in the pressure and the volume during the intake stroke. So what happens during the compression stroke is that the piston starts moving towards the top. So what happens, building up a pressure, compressing all the gases and mixture in it. So we can see the pressure is being increased. Then again comes the combustion process. Combustion process where actually the air and gases molecule have been combust. So where the constant volume process takes place. That is, there is no further increase in the pressure. So the volume is not being made again smaller or larger. Then we'll come to the power stroke. So what happens in the power stroke? The spark ignition is ignited and the volume is being made increase and the pressure is also made push down the piston towards the down. So what happens is that the volume which was there, it drastically comes down, leaving out the gases over there. So in this E direction is nothing but the gases coming out of the all this process being happened. So the exhaust stroke, where the gases are being taken out. So the gases have just been escaped. So there is no effect of the pressure or volume in it. So as usual, the pressure and volume is being constant in the intake stroke and the exhaust stroke on this. So this was all about the four-stroke petrol engine. I hope it was useful. So we had discussed about the parts of it, and we came to the section compression, power stroke, and the exhaust stroke, where you have seen that there was one cycle with two revolutions taking place in it. So I hope it was useful. Thank you for watching.